Hi there, my name is Georgia and I'm going to show you today how to use the LandWISE nutrient budget template. This template was designed to support growers to document their use of nutrients, including good management practices supported by recognised guidelines, and to document their fertiliser plans on a crop-by-crop basis. There are two templates, one for nitrogen and one for phosphorus, as the management and soil testing policies you apply to these nutrients are slightly different. They're available from the LandWISE website and can be downloaded and printed on A4. The templates are designed to integrate recommendations from Nutrient Management for Vegetable Crops in New Zealand by Jeff Reed and Jeff Morton, published by Horticulture New Zealand and the Fertiliser Association. Using the example of a broccoli crop we grew here at the microfarm in Hawke's Bay, I will go step by step on what resources you need to refer to and how the calculations work. So let's get into it. Starting with the first section, I'm entering my name so someone reading this can ask questions if necessary. Next, I'm adding the paddock details, its name, which for this example is Microfarm A, and its size, which is 1 hectare. Now I'm adding the crop name so I can refer to the right nutrient management recommendations later, and its timing, when we planted it and when we're likely to harvest it. Moving on to section 2, the fertiliser plan. Here is where I'm going to use the Nutrient Management for Vegetable Crops book by Jeff Reed and Jeff Morton. The book is a set of recognised guidelines that use expected crop yield and soil fertility levels to recommend fertiliser inputs. In Chapter 5, there are recommendations for cabbage, broccoli and cauliflower crops for the winter planted broccoli. We tested the soil prior to planting and it came back with 90 kilograms per hectare of nitrogen using the potentially available nitrogen test. This gives an estimate of the possible mineralization of organic N, so it is the background N that will become available for plants to take up over the growing season. It's important to record the depth of soil sampling that was done for the nitrogen test. If you're using the nitrate quick test or mineral N test, it's valid to test the full It's important to record the depth of soil sampling that was done for the nitrogen test. If you're using the nitrate quick test or mineral N test, it's valid to test to the full crop rooting depth, which changes according to the crop and throughout the season. However, the available N test is standardized to 15 centimeters for cropping soils. So if you use this test, don't alter the sampling depth. The yield expectation and the soil test results are fed into the guidelines in the Nutrient Management book. See Table 5.1 on page 56 for broccoli, cabbage and cauliflower crops. Feeding in the 16 tonnes per hectare yield expectation and soil nitrogen test of 90 kilograms per hectare, the Nutrient Management Guidelines recommend applying 85 kilograms per hectare of The Nutrient Management Guidelines recommend applying 85 kilograms per hectare of N to grow the crop. For winter planted broccoli, we tested the soil prior to planting and it came back with 90 kilograms per hectare of nitrogen using the potentially available nitrogen test. This gives an estimate of the possible mineralization of organic N, so it is the background N that will become available for plants to take up over the growing season. It's important to record the depth of soil sampling that was done for the nitrogen test. If you're using the nitrate quick test or mineral N test, it's valid to test to the full crop rooting depth, which changes according to the crop and throughout the season. However, the available N test is standardized to 15 centimeters for cropping soils. So if you use this test, don't alter the sampling depth. The yield expectation and the soil test results are fed into the guidelines in the Nutrient Management book. See Table 5.1 on page 56 for broccoli, cabbage and cauliflower crops. Feeding in the 16 tonnes per hectare yield expectation and soil nitrogen test of 90 kilograms per hectare, the Nutrient Management Guidelines recommend applying 85 kilograms per hectare of N to grow the crop. Next, I'm entering the previous crop residue supply, which is the nitrogen from the previous crop residues that will break down and become available over the period of the broccoli crop's growth. You will need to determine a reasonable number by gathering and weighing the residue on the soil surface at planting. Then using either standard values or a lab tissue test, you will multiply the weight of the residue by the nitrogen percentage and make a reasonable assumption about how much N is likely to become available for the crop. See the LandWISE note about crop residues for more info. In our case, the paddock had come out of a grazed barley crop a few weeks before, which is around 1% nitrogen. There were only small scatterings of residue on the soil surface, less than 100 kilograms per hectare, so we will assume that the nitrogen supply from this residue is zero. Now, based on our calculated nitrogen needs and other nutrient requirements, I'm going to plan out what fertilizer we should apply to the crop. Generally, base and starter fertilizers aren't needed with a broccoli crop, as we can apply it once the plants are ready to take it up with placement or banding equipment. About 4 weeks after planting the broccoli, we're going to apply a side dressing of Yarrabella can, which is 27% N. If we apply 150 kilograms per hectare of this product, that will total 41 kilograms per hectare of nitrogen. Splitting up the fertilizer applications will reduce the risk of a heavy rain event causing leaching and the need to apply more fertilizer. To make up the final 44 kilograms of nitrogen required, I'm going to add a second side dressing of N-rich urea at a rate of 100 kilograms per hectare. This brings the total N applied to 87 kilograms per hectare. Moving on to the nitrogen balance. Here the planned surplus or deficit is calculated. This is a straightforward process where nitrogen applied is subtracted from the nitrogen required. If the number is positive, there is a surplus of nitrogen. If it is negative, it's a deficit. In this case, the result is 2 kilograms of nitrogen per hectare, so there is a very small surplus. We think we've got just the right amount of nitrogen planned to go onto this crop. Of course, things may change as the season progresses, so in the next section, we're going to record what we actually did. The final step is to do a post-harvest assessment. This is when we check fertilizer was applied according to plan or if in-season factors caused us to make adjustments. If what we did was different to what we planned, information about these changes can be detailed in the notes box. Starting with the actual fertilizer applied, the 2 fertilizer applications of Yarrabella can and urea were applied as planned. In this example, we had a heavy rain event on the 5th of July. A couple of days later, we tested the soil nitrate levels using the nitrate quick test and found soil N to be low, and an additional 50 kilograms per hectare of urea was applied to achieve our crop yield. This meant the total fertilizer applied was increased to 110 kilograms of N per hectare. Next, I'm entering the date the crop was harvested on. On the left side of step 3, we have a few more boxes to fill in. First, the actual yield we harvested, which we measured by weighing the yield from sampled areas in the paddock. This was calculated to be 11 tonnes per hectare. Next, we enter the nitrogen in this yield. Ideally, we would get this measured by a lab test as well, but for now I'm entering the standard value from the nutrient management book, which states in table 5.2 that broccoli heads contain 4.1 kilograms of N per tonne of yield. After calculating the yield nitrogen, we need to calculate the residue balance. That is, how much N from broccoli residue we are leaving behind, and how much N did the crop have supplied from previous crop residue. As we talked about in step 2, the residue supply from the barley was 0 kilograms of nitrogen per hectare because of the low N percentage and the small amount of residue present on the soil surface. Using the same number as we did in step 2, I'm entering 0 in this box and selecting estimate as we use standard values, not a soil test. After calculating the yield nitrogen, we need to calculate the residue balance. That is, how much N from the broccoli residue are we leaving behind, minus how much N did the crop have supplied from the previous crop residue. As we talked about in step 2, the residue supply from the barley was 0 kilograms of nitrogen per hectare because of the low nitrogen percentage and small amount of residue present on the soil surface. Using the same number we did in step 2, I'm entering 0 in this box and selecting estimate as we use standard values. The residue at harvest from the broccoli crop can also be measured or calculated from standard values. Using the nutrient management book and table 5.2, we can estimate the nitrogen left behind as Using the nutrient management book and table 5.2, we can estimate the nitrogen left behind as 74 tonnes per hectare of crop residue multiplied by 2.8 kilograms of nitrogen per tonne of residue. This gives us an estimated 207 kilograms of nitrogen per hectare of N remaining in the broccoli leaves and stems. Next, we calculate the soil nitrogen balance by entering the soil N at harvest minus the soil N at planting. Whichever test you used at the start of the nutrient budget, you will need to redo at harvest, as to be comparable, you need to use the same test type and sampling depth. As we used lab test available N, we'll use this again after harvest. The soil N at planting was 90 kilograms of N per hectare and was 30 kilograms of N per hectare after harvest. This gives us a balance of negative 60 kilograms of N per hectare. Adding up the changes to the plant N pools of yield exported and residue left behind, as well as the soil N pool, then subtracting the fertilizer N applied, gives us the actual nitrogen balance. That is, the value of nitrogen change in the paddock. In this example, the actual nitrogen balance is 82 kilograms of N per hectare. This represents a nitrogen gain in the system. This means that more N has been added to the system in plant residues, yield, and soil than taken away in leaching, volatilization, or denitrification. While we can't accurately or easily measure nitrogen losses, we can measure the start and end values of soil and plant nitrogen pools, which means we can estimate the difference. If the actual N balance was negative, this would represent a loss of N in the system, either through leaching, volatilization, or denitrification. With both a positive or negative actual N balance, growers should ask how accurate is the data that they're entering. As the more estimates used, the less likely the answer will accurately reflect the crop's nutrient balance. We encourage growers to use lab tissue tests and weighed samples of residue and yield wherever they can to improve confidence in their results. Thanks for watching. Make sure to get in touch with LandWISE with any questions. Thank you for watching, and thank you also to our sponsors. This video was made with support from MPI's Sustainable Farming Fund, Balance Agri-Nutrients, Potatoes New Zealand, Horizons Regional Council, and Gisborne District Council.